Hi guys, today we've got some trigonometry problems which involve trigonometric identities of compounded angles. Now, what we've been given is we've been given A and B are acute angles with the sine of angle A equal to 7/25 and the sine of angle B equaling 3/5. Find the following as exact values. We've got the sine of A take B and the cosine of A plus B. So, to start with, what we're going to do is I'm going to write down what we're going to need to work out the sine of A take B. So the sine, this is our first trigonometric identity. The sine of A take B is going to be equal to the sine of A times the cosine of B. Also take the cosine of A times the sine of B. Now, most people, when they see this question for the first time, what they'll do is they'll go, well, I've got the sine of A and the sine of B, but where the hell am I supposed to get the cosine of B and the cosine of the same angle from? Well, that's where a little bit of Pythagoras comes in and a little bit of lateral thinking. So if we've got these, I've pre-drawn these two triangles here for us to work on. Now, I'm going to say that this triangle here contains angle A, and this triangle here contains angle B. So it means that the sine of A, which is opposite over hypotenuse, so this here is going to be 7. And this here is going to be 25. And sine of B is 3/5. So this is the opposite, is 3 over the hypotenuse, which is 5. So we'll do this one first because it's the easier one. We can use Pythagoras and go, well, the adjacent side here to B, angle B, is going to be 5 squared, which is 25. Take 3 squared, which is 9. So that is 16. The square root of that is 4. Now, this one here, we have 25 squared, which is 625. Take 49, which is equal to 576. And then we're going to do the square root of 576, which, if I'm not mistaken, is 24. You guys can check that if you want, but I'm fairly sure that's right. So what we have is we now have two triangles with all of the sides accounted for. So what we can do now is we can start on part A of the question. So A, we're looking for sine of A minus B. Now for that, we're going to use the sine of A, which we're told in the question is 7/25. So we're just going to substitute it in. Sine of A, which is 7/25, times the cosine of B. Now cosine is adjacent over hypotenuse, so that's going to be 4/5. Subtract the cosine of A, which is 24/25, times the sine of B, which is 3/5. Now, just a bit of this just involves arithmetic from now. 7 4s are 28. 25 times 5 is 125. Subtract 24 times 3 is 72, divided by, again, 125. And we're left with negative 44 on 125. And that cannot be simplified. So that is our solution to part A of this problem. Now, For part B, the cosine of A plus B. Now I'm going to change back, and we're going to need another trigonometric identity. So the compound angle formula for the cosine of two angles, we've got the cosine of A plus B. Now this is going to be equal to, if you do enough of these problems, these trigonometric identities should be like innate, or like should be able to read them off the top of your head like you would a quadratic formula or any kind of like physics or chemistry sort of calculations or sort of, I don't know, ratios that you have to remember. So the cosine of A plus B is going to be equal to the cosine of A times the cosine of B minus, again, it's the opposite sign from what's in the bracket, the sine of A times the sine of B. And so what we're going to do is, using that handy piece of information, we are going to solve B. So we have B here. So the cosine of A plus B is going to be the cosine of A, which is adjacent, 24 over 25. Times the cosine of B, which is 4 over 5. Minus the sine of A, which is 7 over 25. Times the sine of B, which is 3 over 5. Cool. So what we're left with there is 24 times 4 is 96 over 125. Subtract 7 times 3 is 21 over 125. And that is going to be equal to 75 over 125. Now 25 goes into both of these. We've got 3 on the top and 5 at the bottom. So this is going to be equal to 3 over 5. So you can see it's not a hugely complicated question. Like, the questions aren't very hard. The hardest part, I would say, would be committing the trigonometric identities to memory and being able to regurgitate them when asked to. So you've got the sine of an angle, a cosine of a compound angle, and you've also got a tangent one, which we'll address in a different video. But I hope this little explanation helped, and I will see you again next time.